Hello everyone, and our goal today is to teach you how to use ETAP in 5 minutes. So we'll go ahead and we'll start off with a brand new project. You also have the choice obviously of opening up an existing project. In our brand new project, you can essentially build your diagram from scratch using the toolbars, or you can simply go into the template and pick from various pre-built reference designs that we have provided, or you can add your own reference design. You can have entire MCC lineups, or you can have complete substation configurations as well as the engineering data or the reference design for the substations as well. You can also bring in wind farm collector systems and so on and so forth. So the sky's limit in terms of bringing in a existing system. So we can go ahead and bring in one of these systems that we've already built as an option, but if you're unhappy with it, you can simply delete it and start again. When you delete something from ETAP, it always goes to the recycle bin, so you can always bring it back at any point in time or purge it one more time again. Let's go ahead and build a quick model. So we have our power grid, our bus. We want to add a relay, so we can add a CT and a relay, maybe a transformer, perhaps a cable, a bus, and let's say we have 2 motors in the system. So with that, I've quickly built my diagram, and you can see that the program does its best to set up the diagram based on the spacing rules. And we can go ahead and now specify the missing information. This is a 5 MVA transformer, and can simply bring in typical impedance from ANSI or IEC standards. And as far as the cable is concerned, we can put in the length of the cable and pick the cable from the library. And of course, there's also functions available to size and derate the cable as needed. The motor data is already there based on our default data, which you can always change, but we're ready now to run our power flow calculation, and you can see the results directly on the diagram. The units are turned on, so you can essentially quickly toggle between them, or you can simply switch between different types of units, in this case kilowatt, volts, or percent for the voltage, or you can also turn on and see the kVA and the amps for the network. So our load flow is done. Let's go ahead and switch over to short circuit, run the computation, and the program does a terrific job at letting you know that you're missing information. So you can double click on the error message. It takes you to the component that has the issue, and you can plug in the data to complete your study. We're running a fault analysis, so I would like to go ahead and fault this particular bus and run the calculation again, and we can see the fault contribution from the feeder as well as from the individual machines in the network. Ready to do a TCC curve? No problem, very quick and easy. You can simply go to the CT, type in a CT ratio, go into the relay, make sure we have an output specified. Look, I forgot to add a breaker, not a problem. So what we can do is quickly come in here, add in a breaker. No need to break connections. The program simply allows you to snap the breaker in line. Now we can go back to defining the output for this relay, which needs a digital output, and it's going to be circuit breaker number 2. So that's automatically interlocked for me. And then from the library, which is verified and validated, you can pick from all of these different vendors and pick your favorite vendor if you'd like from here. So we'll pick a Schneider relay, which is a MICOM. And it sets up the relay based on its functions, OCR, OLR, as well as distance functions. So you can specify all those details. We'll turn off the instantaneous for the time being and set our curve to an IEC curve. So we can go ahead and now select this entire diagram and go ahead and plot it into our TCC. So we can see the relay curve, we can see the cable damage curve, the transformer damage curve, and the motor curve. If you're ready to remove details from this, you can simply press delete. It doesn't affect the diagram, but only affects the TCC itself. And here we can see our setting page is set for Schneider P44. And if you're ready to change the time dial, you can just simply adjust the time dial up or down, or change the pickup for this particular relay. And this automatically updates the database everywhere. Ready to test this protection? No problem, just simply drag and drop the short circuit arrow. Once again, the program is letting me know that I picked a cable that is missing some information, so we'll go ahead and pick a different conductor and rerun our test again, and we can see that this relay picks up and trips the breaker in 283 milliseconds. So very quickly you can also see a sequence of operation directly on the diagram. And with that, we can switch over to arc flash, run our arc flash computation. We need to select a bus where we want to fault, so we can right click and fault, run our arc flash study. The program gives a warning that the PPE requirements have not been approved, so it's essentially doing a safety check. And then based on the current short circuit results and the relay setting in the network, we can see what the arcing current is, as well as the arc flash energy. So from here, you're ready to go to the arc flash page, see more details, or go inside the sequence of operation for arc flash, and you can investigate in more detail what's going on inside this network, who's tripping and at what stage. And once you're happy with that, you can simply go inside the arc flash analyzer, and from here you also have the possibility of printing labels, work permits, data sheets, and a whole lot more. So within 5 minutes, we've shown you how easy it is to build a diagram and run the calculations within ETAP, going all the way from load flow to short circuit to protection to arc flash. Thank you.